So we've covered trust and what it means to have trusted data and why it's so foundational in terms of bridging the gap between these new intelligent graph models and privacy. But the other really important element to creating trusted systems is how portable the data is. So think of how many things in healthcare require some form of data sharing. It's pretty much everything. And think about how many of those processes involve someone manually looking up the data or double checking to make sure that the data is right. The amount of overhead involved with health data sharing is staggering, and it's all because we're missing that trust layer. So how do we bring in that trust into data sharing? There's really three different factors to consider in how you build trusted data sharing and trusted data exchange systems. The first is how you configure the network itself. The second is how you're managing consent and governance, which is essentially the set of rules around how data is allowed to be shared. And the third is how you're packaging up that data so that it can be read and trusted by other systems. So let's talk about the network first. This is a pretty typical setup in the hardware, in the healthcare space. You have EMR systems, rev cycle management systems, analytics. They all have their own databases. Maybe there's a data warehouse thrown in the mix somewhere. And then there's all these external integrations with HIEs, vendors, reporting systems, on and on and on and on. These kinds of networks are really difficult to manage because each of these endpoints has a different type of data that may not communicate very well with the other parts of the network. So in addition to maintaining all of these actual connections, you have to enforce a bunch of interoperability standards, and you have to manage data governance for each of these connections. And then there's another problem with these types of networks, and that's data consistency. There's no source of truth that allows each endpoint to know what data is the right data. So if two systems, if two endpoints are storing my name, but one of them is misspelled, there's no way for the system to know which version is actually correct. And there's one more really major catch, and that's every time an endpoint shares data with another endpoint, they're moving data into a database that they don't control. And so every time they do that, they lose that data or they lose control of that data. So that puts us back into the situation that we were talking with at the beginning, where you're being forced to trust the entity that controls the data instead of trusting the data itself. So one way to address those spaghetti networks has been to create more of a hub and spoke kind of model. So this definitely simplifies things in terms of network management, but again, you run into the same issue as before. If you don't control the hub, then you don't control the data that you're sharing with the hub. And that puts us back in the position of needing to trust the entity that controls the hub. The other challenge with these centralized models is when you're trying to use them for analytics and AI. So typically, a hub and spoke model will force data into a certain standard to make the system easier to manage. But when you do that, you run the risk of losing some specificity in the data. So let's say, for example, I might have one EMR in my system that captures 5 different gender definitions, and another EMR in my system that only captures 2 definitions. If you standardize the system to 2 genders, because it's the common denominator, you really limit the potential of that data from a research and analytics perspective. By applying that 2-gender standard to the hub, you've lost the ability to do things like, if I wanted to study healthcare inequity for non-conforming genders, I would have no ability to do that because that granularity is gone. So trusted data networks solve both of these problems. The core principle of a trusted data network is that each participating entity, whether it's an organization or a person, is able to use trusted data as a way of sharing data without losing control of it. The data can be shared and moved around, but because the access rights are built into the data itself, the owner can revoke access, and that will be enforced even if the data has been moved someplace else. The other key principle of a trusted data network is governance. There are a few different ways that governance can be managed in a trusted data network, and how you set it up really depends on what you're trying to do. So one way is to use a neutral governing body that sets and maintains the governance model so that data sharing between participants always follows that governance model. One other way would be to have a subset of your participating entities really act as kind of a governing board. And then the last way is really the most democratic way, and that would be to have every single participant in your network contribute collectively to the common governance model. There's another nuance here that you can see, which is that there are probably going to be multiple layers of governance, especially when the network is handling personal data. So we call that multi-layered governance, and it's always going to be an issue with an identity and health data because of how consent is regulated. If you are treating all of these different layers as separate things, and you have a consent management solution and a data governance solution and a regulatory compliance solution, your system is going to get really bogged down. So it's important to see all of these layers as pieces of a puzzle. All these layers have to work together to manage how data is allowed to be shared on a network. And they all have to be flexible enough so that when people revoke consent or regulations change, the network can adapt to those changes without having to rebuild the entire model. I mentioned before the challenges about spaghetti networks and hub and spokes, and the challenges that they have around data standardization and how that impacts AI and analytics. There's a few different ways to address this, but the most important thing here is to have flexibility in terms of how your network is set up. So we use a flexible schema model, and that means that standards can be applied in a more dynamic way. So I can store my data with all 5 genders, and when I present that data to a 2-gender EMR, I can apply a 2-gender standard. When I present that data to an analytics tool, I present all 5 genders. When you're trying to connect hundreds of different applications together that all use different types of standards, that kind of flexibility makes things a lot easier to manage.